Okay, fifth graders. Like I did the other day, I'm going to do this one ahead of time. Got a few extra minutes this morning. Thought I'd give it a shot. It worked pretty well. So we're looking at 3.9, and it's page 143. So it says unlock the problem. Hannah has 3.36 kilograms of apples and 2.28 kilograms of oranges, and estimates that she has about 1 more kilogram of apples than oranges. How many more kilograms of apples than oranges does Hannah have? And how can you use this estimate to decide if your answer is reasonable? So over here in the box it says, what operation will you use to solve the problem? Well, subtraction. Okay. And then it says subtract 3 point, well, we're going to subtract 2.28 from 3.36. And it says subtract the hundredths first, and if there are not enough hundredths, regroup the 1/10 as 10 hundredths. Well, we've done a bunch of problems like this. So it's going to be 16 hundredths. All right, and then subtract the tenths and the ones, regroup as needed, and it's going to be 2 tenths and 3 ones, and we can actually do the problem right here. So I'll let you guys go ahead and do that, and we'll see what the answer is. And I could pull a stick. So everybody do this right now. And let's see here. Mr. Milmore, you're up. What did you get? And I have no idea if you got it right or not, or if you even if you even finished it. But if you got it right, you can put up 20 points. If you got it wrong, the answer should be 1.08 is what you guys should have gotten. All right. Let's see here. I never thought about pulling sticks while I was recording the videos. That's kind of fun. Think of new things every day. Okay, let's move down here. Draw a quick picture to check your work. We've done these ad nauseum, which is Latin for too much, too many times. So I'm not worried about you guys drawing any pictures. So let's see here. So Hannah has 1.08 more kilograms of apples than oranges. Since 1.08 is close to 1, the answer is reasonable. And remember, we were looking to see when she said that she had 1 more kilogram, we wanted to know if that answer was reasonable, and it was. Okay, next page. This is page 144. All right, we're getting into some meat here. Since subtraction and addition are inverse operations. Inverse operations, what does that mean? You can check subtraction by adding. Inverse operations, opposite operations. So let's see here. Find the difference. Subtract the hundredths first, then subtract the tens, ones, and... Well, you guys know how to do these, so everybody can do this one right now. You can put a 0 right there, and as sort of a placeholder. So everybody can do this one, and I can pull a stick to see if you guys got it right. This is fun. Let's see here. Miss Hicks, did you get it yet? You go ahead and do that one real quick. I'll wait a moment. Because I know you usually get them right, but it takes you a little bit longer. And that's okay, as long as the answer is right. I'll take a sip of coffee. See, here's my coffee this morning. Did you get it yet? Well, if you got it right, you can get some points here, 20 points. So we can't take 3 from 0, so we're going to have to borrow. That becomes 1. And then this becomes a 10 now. And so 3 from 10 is 7. We can't take 6 from 1, so we're going to have to borrow. This becomes a 3, and the 1 becomes 11. 6 from 11 is 5. And then we can drop down the decimal straight down. Again, we can't take 8 from 3, so we have to borrow. This becomes a 0. The 3 becomes a 13. 8 from 13 is 5. And so the answer is 5.57. If you got it right, Miss Hicks, you can put up 20 points. All right. Now, over here it says check your answer. Okay? So, the difference, this is the difference between the two, between these two numbers. This is the difference. And so we're going to put the difference right here, 5.57. 5.57. And this is what they're talking about to check your answer when you're dealing with inverse operations. You can check subtraction by adding. So we're going to add these two together here. And if you do, you're going to end up with 14.20. And if that matches this, which it does, then you know your answer is correct. All right. Let's see here. Could you have also checked by... I'm surprised they don't point this out here. If I took the difference again, 5.57, and instead of using 8.63, no, I take that back. That's not going to work. Trying to think of a... I'm drawing a blank here. I'll have another sip of coffee. Let's see here. No, nix that idea. Added. No, that's not going to work. No, okay, never mind. My thinking was wrong. Well, what do you expect first thing in the morning? Okay, let's see here. Evaluate. Is your answer correct? Well, yeah, I know it is. Okay, not worried about that one. Estimate. Okay. So we did several of these yesterday. So let's estimate to the whole number here. So I'll do the first couple with you. So is this 5 or larger? Because this is what we're dealing with here. We're talking about the ones place. This is what may or may not change. Yes, that's 5 or larger, so this is going to be 6. Is this 5 or larger? No, it's less than 5. And so this is going to stay the same, 2, and 6 and 2 is 8. So that's what I want you to do in the first ones. And then go ahead and then find the difference. Then, after we estimate, then find the difference. So go ahead and do the subtraction here. Let's estimate one more here. Again, we're going to deal with just the ones place here. Is this 5 or larger? Okay, no, so the 4 stays the same. Is this 5 or larger? Yes, so this one becomes a 2. And the estimate, 4 and 2, is 6. So go ahead and do all these, and we'll check those. Next page. Oh, we did some like this just yesterday. I think you guys remember. 3 72/100 subtracted from 5 81/100. Well, let's get these down and correct first. So 3 72/100. So I gave you an example yesterday. Okay. So 3, and then if we're talking about hundredths, we're going to go to this place here. 72/100. 72. So it's 3.72. All right. And we're going to subtract that from 5. That's going to be the first number, 5. I'll put a decimal there. And 81 hundredths. So here's the hundredths place, so it's going to be 81. Okay? You guys know these are the ones. This is the tenths, hundredths, thousandths place, 10 thousandths. Okay? So you're going to subtract 3.72 from 5.81. So I'll just go ahead and do this. 5.81 and 3.72. You're going to subtract that and then just tell me what the answer is and write it here. And you'll do that for both of those. Okay? Ooh, algebra. I love algebra. Okay? Use reasoning, algebra. Write the unknown number for n. Don't let these letters scare you. Okay? Because it's really easy. Let me give you a couple examples. You guys pay close attention here. Look. What if I wrote 3 minus 2 equals n? Okay. Well, I just need to find what n is. 3 minus 2 is what? 1. So 3 minus 2 is 1, so 1 equals n. All right? Now, that was easy because all we had to do is solve for n by doing the problem, by doing the subtraction. Sometimes they might have a problem that looks like this. How about 10 subtracting n equals 4? Okay? Well, oh my gosh, how would you solve something like that? It looks so confusing. Now, in the examples they give us here, or the problems they're giving us, they're decimals. But I'm just showing you with whole numbers right now, just to keep it simple here. So whenever you do algebra, and you guys will be doing more of this as the years go on here, especially come 8th, 7th, and 8th grade, to solve for the variable, the letter is called the variable. You do the opposite. Okay, so and you want to get the variable by itself. I'm going to show you a really simple step to do. Okay, so you know what? Gosh, that was not. I'm gonna change this. I'm gonna do n minus 10 equals equals 5. Okay. The reason I nixed this one is because the way I set it up, you'd end up with a negative variable, and that would be an extra step, and I didn't want to confuse you guys. So let's just go with this here. N minus 10 equals 5. So we want to get the variable all by itself. And maybe I'm going in too deep into this, but I couldn't help it. I saw the word algebra, and I had to show you guys. So look, we want to get n all by itself. So what's happening to the n? It's being subtracted by 10, so we're going to do the opposite. We're going to add 10, and whatever you do on one side of the equation, you do on the other. So negative 10 plus 10 is what? That's going to be 0. So we're left with just n over here. What's 5 plus 10? That's 15. So n equals 15, and we look and see if that makes sense. What if I put 15, if n is 15, if I put 15 minus 10 equals 5, you can see that that does work. Now, these here are probably not that complicated, and maybe I was making it harder than it was. This one is like the very first one I did. So you're just going to subtract 3.4 from 5.28 to get n. This one is like the second one I just did. Okay? What's happening to the n? Okay? We want to know what n is, but what's happening to it? Well, it's being subtracted by 6.47. Well, we want to get n all by itself. See, whenever we get a variable by itself, and when I say by itself, this is what I mean. What if I had a problem like this? And you guys will have problems like this. What if I had n plus 5.6 minus 7.2 equals 37. Well, if I wanted to find out when n is, I need to get rid of these, because then I'm just left with n on one side of the equation. Okay, so whatever n is, I'll know it because I'll have my answer right here. Just, you want to get the variable all by itself on one side of the equation. So that's, again, that's what we're doing right here. So I'm going to add 6.47 to both sides of the equation, 6.47. Remember, whatever you do on one side of the equation, you do on the other. And this negative 6.47 plus 6.47 is what? That's nothing. It's 0. We're left with just n over here equals, and then you just add these two together, 4.32 and 6.47, and then you'll know what n is. Okay? All right, how about this one here? Well, this is more like that one that was a little more difficult that I was talking about, but I'm kind of surprised they said it this way. So, how are we doing on time here? Oh, wow, we're past 15 minutes. So we want to get rid of this so we can get n by itself. Wow. So, you are going to subtract 11.57. Subtract 11.57 on both sides of the equation. Now, in this case, I'm probably thinking the easier step for you guys would be just to find the difference between the two, 11.57. And we're going to subtract 7.51. And you're just going to tell me the difference between those two, and that will equal n. All right? So whenever you have a minus variable, just find the difference between the two numbers. Okay? And I'll walk these, if they have more of these later on, I'll walk through them with you. This one can be kind of confusing as to the way I explained it. But anyways, so give those a shot, and you can go ahead and find the differences in these. Finish this page up. You can do this one too. I'll do a homework video. And gosh, then we're back to 3.6. That's the end of the packet. So, or this packet. I don't think it's the end of chapter 3 though. So, okay, that's it.